we'll be talking about experiment 6, the activity series. So there will be two parts to this experiment. Part A is looking at reactions of metal with acids. In this case, we'll be looking at metals with 6 molar hydrochloric acid. Pieces of metal that you'll be using will be calcium, copper, iron, magnesium, tin, and zinc. So we're going to observe if there are any reactions, such as the evolution of gas, any color changes. If there are no reactions immediately at room temperature, we're going to put it into a beaker of hot water and give it a few minutes to see whether or not the heat will help start the reaction or help speed up the reaction. We'll write our observations, and then if there is a reaction, we'll write the molecular, the total ionic, and the net ionic equation for each of the reactions that has occurred. So your data table looks like this. If you'll write your observation here. If there's a reaction without adding any heat, then just write not applicable. If there is no reaction, then write down no reaction, and then you write down your observations with heat. Okay. If there's no reaction after heat's been added, then you just write no reaction again. So what we do is we basically, on the white coated parts of our test tube, use pencil, and we label our test tube. So we have calcium, copper, iron, magnesium, tin, and zinc. This test tube is just going to have 2 milliliters of water. So since this is qualitative, you'll match that height with your hydrochloric acid. So hot beaker of hot water, you're going to use DI water for this. Use your calcium, copper. Instead of steel wool for the iron, we're going to use an iron nail. You're going to put the head down first, not the point, when you put it in the test tube. You have your magnesium, your tin, and your zinc. We have here sandpaper, so in case there's an oxide layer on your metal, you can use a sandpaper to abrade it off, and then that'll help enhance the reaction. You don't have to have it react with an oxide layer first. And we have a waste beaker, so we don't have to run over to the waste hood every single time. We'll finish our set of reactions and then empty them all into our waste beaker. And at the end of the class, when you're done with all your reactions, you take it, empty it into your waste beaker in the back for the class. Okay. So here again, here's my 2 milliliters of water. And we have tin. So here's our tin foil. Okay. Now, if you're concerned that they're oxidized on the surface, we have sandpaper, so you can sand it just to make sure it's reactive. So like with magnesium, you can just sand it. Just go here, just remove the darker part. You can see that it's shinier. Okay, here's your magnesium. For the iron, you can use steel wool, or in this case, you can also use an iron nail. Okay, so I'm going to go ahead and put an iron nail in here. We have copper. Finally, we have calcium
calcium is very reactive, inflammable, so you don't need you just need a pinch. And as always, when you finish, make sure you put the lid back on. You return it to its rightful place. This will prevent it from going bad with exposure to air and the water in air. Okay. Now, since we know this is a height for our 2 milliliters, we're going to do one at a time. Okay. And then just watch it. If nothing happens, we'll put it in the hot water. So we'll do first our zinc. Okay. And all you're going to do is add enough 6 molar HCl. Okay. As you can see, almost immediately when you put in your hydrochloric acid, it begins to bubble. All right. So we know we're getting bubbling, reactions occurring.
We can see here the bubbles from our reaction. Okay. Now let's look at tin.
Okay, so now we're going to do the same thing with our tin foil. Okay. And if you look at it, not too much is happening, at least not immediately.
So what we're going to do is we're going to go ahead and put our tin and the hydrochloric acid, this test tube, in the hot water to let it heat. In the meantime, we'll look at our next piece of metal. Okay, so this is what it looked like before we heat it. After we heat it, you can see that there are bubbles forming. So it took a little time and some heat to encourage getting a reaction to go. Now, here's our zinc. Here's our tin. Let's take a look at magnesium.
Okay, so with the tin foil, we don't see much reaction occurring. So what we're going to do is we're going to put this in our hot water. Okay. And we'll give it about 5 minutes and then check it again. All right. So what are we looking for? We're looking for either a color change. Because nothing happened, the one thing I didn't feel for was heat. We're looking for a color change. We're looking for a formation of bubbles. All right. So while that's occurring, let's see what happens with magnesium. Let's see if anything's happening here yet. So the reason that we want to heat it, of course, before I go on to magnesium, is some reactions occur quickly, like what we saw here with the zinc, and some may react slowly, and some might not react at all. So that's why we want to heat it to see if there's a reaction at all. So with the magnesium, again, we'll put in our 2 milliliters, and again, it immediately bubbles.
So we know there's a reaction for magnesium. Again, here you can see we don't even need the assistance of heat, the formation of bubbles, so we know a reaction is occurring between magnesium and 6 molar hydrochloric acid. Now, let's take a look at iron. So, as I showed you earlier with tin, you saw after heating there was a reaction. If we take a look at iron, we add our hydrochloric acid.
Okay, so now you can see there's absolutely no magnesium left. It completely reacted with the hydrochloric acid. We showed you some pictures what happened upon heating for your tin foil. You can, and then the zinc is still reacting. You can still see it's forming bubbles. So let's move on to our iron nail. Okay. We'll do basically a couple milliliters. Okay. And when you take a look at it, there's no immediate reaction, but if we take a closer look, you might be able to see a reaction.
So let's take a closer look. Took a little time because we had to remove the oxide layer, but now you can see that without heating, iron reacts with 6 molar hydrochloric acid.
Okay, so now we're going to do hydrochloric acid with the copper. Okay, and that's going to be about 2 milliliters. And you can see nothing's happening. This one had bubbles. That nothing happened. And so when we put it in the hot water, magnesium is completely dissolved and zinc is still reacting. So, because I don't see bubbles or any change in color, I'm going to go ahead and, like the tin foil, I'm going to go ahead and put it into the hot water. So while we're waiting for that, let's take a look at see what happens to the calcium. So let's put our 2 milliliters of hydrochloric acid in the calcium. And you can see just upon addition, it's immediately bubbling. And if we feel your test tube, it's very hot.
In your data table, you're going to complete your observations.
Okay, so when you write your data table, and I'll have a template for you for part A and for part B, the reason I have 2 separate lines for each metal is that if we don't have a reaction, we need to heat it and then record the reaction if we heated it. So on the top line, that's just at room temperature. On the bottom line, and A, it's not applicable because we had a reaction, I didn't need to heat it. If I had no reaction, I heated it, and then I recorded it. In this case, I recorded in red for hot. Okay, and then these 2 had reactions. And tin, we didn't see a reaction at room temperature. But once I heated it, we can start seeing that there is a reaction. We started seeing the formation of bubbles. And the last one had a reaction at room temperature, so I didn't need to heat it. Now, when we do our calculations, we'll be doing this at home, okay? You need to go through and write down the molecular and net ionic equation, okay? So in this case, there was a reaction, and if you look, we had calcium solid, okay? Plus we added hydrochloric acid in the aqueous form, all right? And we formed calcium chloride, which is soluble in water, plus hydrogen gas. And so one of the things is when we're doing the activity series, since we're doing single displacements, metals often form hydrogen gas when they do have the reaction. That's why we saw all that bubbling. So this explains the bubbling, okay? The reaction is exothermic, that's why it's formed. It's not balanced, so make sure you balance it. Okay, so you have something like that. This is my molecular equation. Now what's my net ionic? So in between, you can do this on scratch page, and then just do it as an appendix, turn in all your original pages. What you're going to see is that really it's the calcium reacting with your acid, the H+. And what you do is the electron of calcium donated or transferred to my hydrogen, and this becomes calcium solid, calcium 2+. So this is my ionic, and this is my molecular equation. Okay, so molecular, then ionic. So here for copper, I'll just do copper, and then you can do the rest. But for reaction at room temperature and no reaction at under heating, then you just write no reaction. So you can just put down copper plus hydrochloric acid, no reaction. Okay, so let me explain these two before we go through and look at part B. When I have no reaction, what that means is that hydrogen is more reactive than copper. Okay, so hydrogen has a greater reactivity than copper. If I have a reaction, this means that my calcium has a greater activity than hydrogen. Okay, so you're going to just finish just doing your molecular and your net ionic equations for part A.
Okay, so let's move on to part B. In part B, we're going to look at the reactions of metals with solutions of metal ions. Again, we have prepared the table for you, and so you're going to write down your observations. And from your observations, you're going to determine which metal is more active in the activity series, so which metal is more likely to be oxidized. Okay, so when we look at it, we're going to have my calcium nitrate solution, my cupric nitrate solution, iron 2 sulfate, iron 3 nitrate, magnesium nitrate, tin 4 chloride, and zinc nitrate. Okay, make sure you note any reactions that occur. If there's no reaction at room temperature, we'll reheat it and then reevaluate. Okay, when we discard the waste, we discard it in our waste container and then rinse it, and then we can wash it in our sinks. Okay, we'll do calcium first and then copper, and then iron, magnesium, tin. And in this case, for your presentation, we did not have enough videos for zinc. So based on your observations with the zinc nitrate solution, you will still be able to determine its activity relative to the other metals. All right, so this is what your activity, the data table looks like. The numbers here just represent which reaction you're doing, so you can associate the appropriate molecular, complete, and net ionic equations with it. Okay, because iron 2 sulfate oxidizes easily with the oxygen in the air, we make it fresh. So this is basically how we're making 0.2 molar solution, 25 milliliters. So this is how much iron 2 sulfate that we had to weigh out before we made our solution. So here we labeled all of our test tubes, okay, with the appropriate solution. And here we have our 2 milliliters of water, so we know the height to fill our test tubes. And here's your calcium nitrate, cupric nitrate, ferrous sulfate, ferric nitrate, magnesium nitrate, tin 4 chloride, and your zinc nitrate solutions. And over here is where you would have your hot plate and your beaker of hot water if you need to heat up your solution. Okay, so this is my water, and here is my calcium.
For this sample of calcium, we're going to add 2 milliliters of 0.2 molar ferrous sulfate, and you can see a vigorous reaction occurring. You can hear the bubbling. Okay. I'm going to add 2 milliliters of 0.5 molar cupric nitrate to the calcium. You can see there's a very vigorous reaction. Add 2 milliliters of 0.2 molar ferric nitrate. Again, you're going to see a vigorous reaction, and note the color changes as well. So here we're going to go ahead and add calcium nitrate, 2 mils to our calcium, and you can see it's beginning to bubble. Sample of calcium, we're now going to add tin fluorochloride, 0.2 molar solution. You can hear the formation of gases, all the bubbles. So again, a nice vigorous reaction. For this sample of magnesium, calcium, we're going to add magnesium nitrate, you see a vigorous reaction occurring. Our last reaction is going to be with calcium metal and zinc nitrate. And then we'll move on to our next metal. So let's take a look. With the calcium metal and the zinc nitrate, we get a reaction. You can see the bubbles forming.
Okay, so here are our results from calcium, okay, metal with our various solutions, and even with the calcium nitrate, you're going to see that there is some bubbling. So you'll see that calcium metal reacted with every single solution. Let's take a look at copper, and we're going to look at copper with our
Now we're going to do our
solutions.
next metal, which is copper. So we're going to add 2 milliliters of the 0.1 molar calcium nitrate to copper. Okay. And it doesn't look like anything's happening. There's no reaction and there's no bubbling. So what we're going to do is you're going to heat this. So you're going to take your test tube and you're going to put it in the hot water here. Okay, and we'll let it heat up for about 5 minutes while we do the next reaction. Add 2 milliliters of 0.5 molar cupric nitrate to the copper. And if nothing happens, then we're going to go ahead and heat it. As you can see, nothing's really happening. The copper's just floating on it. So we'll put it in the hot water and we'll move on to the next one. This one, we're going to add 2 milliliters of 0.2 molar ferrous sulfate to the copper. To see what happens. In this case, we don't get any discoloration or bubbling. So this one, nothing's happening, so we're going to have to go ahead and warm that up as well. We're going to go ahead and add iron 3 nitrate, ferric nitrate, to our copper. And we don't see much happening, so we're going to put that in the hot water. And so how will we know what we're doing? Because remember, we've labeled all of our test tubes. So we know this is the ferric nitrate. This one had the calcium nitrate. This one had the ferrous sulfate. And this one had the cuprin nitrate. This is our calcium nitrate with copper after heating for 5 minutes, and you can see there's been no reaction. The next one, which is our cuprin nitrate. Again, look at the copper metal looks good, and cuprin nitrate stays a nice blue. After 5 minutes of heating, there's been no reaction. The third one is R120 sulfate. If you get a close look, there's been no reaction. The solution looks basically the same as the original solution. You can see the copper on the metal on the bottom stayed the same color. There's been no reaction. R120 nitrate, as you can see, the solution is pretty much the same color, and the copper is the same color. After heating, there's been no reaction. 2 milliliters of magnesium nitrate to our copper metal. Okay, there's been no color change. Been no reaction so far, so we're going to have to heat this 5 minutes. While that's heating, let's take a look at our tin 4 chloride. We'll add 2 milliliters. Again, no color change, no reaction so far, so we'll heat it. And the last one we're going to look at, we're going to be adding 2 milliliters of zinc nitrate. And you can see there's been no color change to the metal or the solution, no bubbling. So right now, nothing's happening. We're going to have to heat it. So we'll let those 3 heat for about 5 minutes. Okay, so if you look at your copper metal with the magnesium nitrate solution, there's been no reaction even after 5 minutes of heating. If we look at the tin 4 chloride solution with the copper metal, you can see there's been no reaction. And finally, even after heating, the zinc nitrate with the copper metal shows no reaction. So copper hasn't reacted with anything.
So essentially, copper is very inert and hasn't reacted with any solution. So we'll move on to our next metal, which will be iron.
We're now going to be looking at the metal iron, and we're going to be using an iron nail to represent it. And if you can focus in on the bottom part of the test tube on the nail, that's where you're going to see a reaction if there is one. So the first one we're going to do is add 2 milliliters of calcium nitrate to the bottom of our nail. Okay. And if there is no reaction to this, okay, we'll have to heat it to see if anything occurs. Okay, keep an eye on the iron nail. I'm now going to add in 2 milliliters of the copper nitrate, copper 2 nitrate. And so we don't see any bubbles forming, but what we want to keep an eye on for this is whether or not there's a change in color as well. If we don't see anything immediately, what we're going to do is we'll go ahead and heat that up. And while we're waiting for that to, if anything happens there, we'll go ahead and do the next one. Okay. So the next one is adding iron 2 milliliters of iron 2 to our iron. And at this point, don't quite see anything happening, so we'll go ahead and put that into our solution to heat it up, to the water. Heat it up. Fourth one is going to be adding iron 3 nitrate to our iron nail. And what we're looking for is any type of reaction. Okay, and that may also include a change in color, but right now there's nothing obvious happening. So I'm going to go ahead and put that into the heat. Iron with magnesium nitrate. Anything happening? Not really, so we'll go. This will be iron and tin 4 chloride. Okay. So you can see actually something's beginning to happen already. Alright, it's a little slow, but you can see there's been a small color change with iron. But we'll go ahead and heat that up and see if we can't encourage that reaction to continue. But you can see that the solution is already getting a little cloudy. So this reaction is occurring even without heating. Okay, but I'm going to go ahead and warm it up. And then this last one is going to be iron with zinc nitrate. Okay, so far not too much, so I'm going to go ahead and put that in the hot water.
Okay, so let's see what the results are. So here, doesn't let much has happened. This is my calcium nitrate with iron. Here you can see that a lot has happened. That's with my cupric nitrate with iron. Iron 2 sulfate and iron 3 nitrate. Not too much has happened there. Then, if we look, the magnesium nitrate, this is still pretty clear. As you can see, there's just a tinge of a change in color there. And we're concerned about the opacity of that. And then with the zinc nitrate, excuse me, you can see it's just as clear as when we started. So it looks like if there is going to be a reaction, even after the heating, it would be with a tin 4 chloride. Alright, so now let's go ahead and take a look at magnesium with our solutions.
We're going to be looking at the metal magnesium, and it'll be magnesium with 2 mils of calcium nitrate. Okay, nothing seems to be happening there, so I'll put it in the hot water in a moment. This is going to be cupric nitrate with the magnesium. Okay. Anything happening here? We'll take a look. Okay, Okay, this is going to be 2 milliliters of ferrous sulfate, the magnesium. Okay, this is going to be 0.2 molar iron 3 nitrate. Okay, what we're looking for is we're going to be looking for changes in color. Okay, so this is going to be magnesium with magnesium nitrate. This will be magnesium with tin 4. Look what's happening already with magnesium and tin 4. It's a pretty vigorous reaction. Okay, and now this is going to be up here. Just show you. I'm going to move this down. Can you see it? Okay, so here's magnesium with my zinc nitrate. So, the one that had a vigorous reaction right now was the tin 4, but we're going to have to take a look at the others after we heat it.
Alright, so let's take a look. Magnesium and calcium nitrate. Doesn't look like there's much change. And here, if you look at the copper and copper nitrate magnesium, look what happened to the color of my magnesium strip. It's much, much darker. It's almost black. Here, this is magnesium in my ferric nitrate and magnesium with my ferrous sulfate. We saw a vigorous reaction even before heating with magnesium and tin 4 chloride and my magnesium and magnesium nitrate. Looks like nothing's happened there. And finally, the magnesium and zinc nitrate solution doesn't look like a lot has happened there. Okay, so calcium nitrate, copper 2 nitrate. You can see there's some color change here. I have my iron 2 sulfate here, my iron 3 nitrate there. This is magnesium and magnesium nitrate, magnesium and tin 4 chloride, and magnesium with my zinc nitrate. Now let's take a look at tin. If we look at the tin and the calcium nitrate, this is going to be after heating. You can see there's no reaction. The tin and the copper 2 nitrate, you can see the opacity of the copper 2 nitrate. There's a reaction there. Here is my tin with the iron 2 sulfate. It's a little cloudy, but look at the tin with the iron 3 nitrate. It's nice and clear, just as if we first put it together. If we continue, tin with magnesium nitrate, it looks like nothing happened. Then tin with tin 4 chloride, looks like nothing happened. And the tin with the zinc nitrate, it looks like nothing happened even after heating. That's why you see some steam in here. It's after the heating. Okay, so now all you're going to do is you're going to write down your reactions. So for an example, for part A, reactions of metals with acid. Calcium with the acid under no heat, so we know it's at room temperature. We saw vigorous bubbling, so we write not applicable here. Then at the end on your data tables, you're going to see 1, the calcium, you add in hydrochloric acid, you're going to write your balanced equation, your complete ionic, and then your net ionic. And then part C, this is actually from, you're going to do the activity series, but it's going to be based on part B, not part A. But if you just do your example, because you saw a reaction, then you know that calcium is much higher in activity than hydrogen. So you're going to do that. You're going to determine which is more active in a reaction from your part B series, and then overall determine your activity series for all 6 metals.